to Insinyur.
The 11th International Conference of Energy, Environment, and Information Systems 2026, in conjunction with the 8th Annual Scientific Meeting of the Indonesian Groundwater Experts Association. Sustainable Tomorrow, redefining a holistic environmental social governance approach to energy, groundwater, and information systems. This event is sponsored by
Good morning, distinguished guests, honorable speakers, and all delegates. A very warm welcome back to Day 2 of our 11th International Conference on Energy, Environment, and Sustainability, and the 8th Annual Scientific Meeting of the Indonesian Groundwater Experts Association, PAAI.
Good morning, everyone. Welcome back. I hope everyone is doing great today. How about you, Sakti?
I'm feeling very good today. Yesterday was packed with brilliant insights, starting from the soft launching of our thesis to the very insightful panel discussions and parallel sessions.
It really was. And today promises is just to be as exciting. We have the second panel discussion coming up, sponsor presentation session, and the final round of the 3-minute talk competition, and of course, our grand awarding closing ceremony.
So, ladies and gentlemen, take your seats and let us dive straight into our Day 2 program.
To start off our morning session, we move directly to the second panel discussion with the theme, Building for a Sustainable Tomorrow, Driving ESG Excellence Through the Energy Efficient Infrastructure and Hydrogeology.
Our panel brings together distinguished global experts, Professor Dr. Syahrul Nizam bin Kamaruzaman, Dr. Stefan Herwig Godeke, Dr. Nur Syafina binti Roslan, and Dr. Irwan Iskandar, PhD.
This session will be moderated by Insinyur Marcelinus Kriswardana, PhD, and to all the panelists, the floor is yours.
Okay, good morning, distinguished speakers, respect, respected guests, colleagues, researchers, students, ladies and gentlemen. Welcome to second panel session of ICENIS. It's my honor to serve as moderator for today's session under the theme, Building for a Sustainable Tomorrow, Driving ESG Excellence through Energy Efficient Infrastructure and Hydrogeology. We have 4 distinguished speakers with us today. And all 4 speakers will deliver their presentation consecutively, 10 minutes each. 10 minutes? Yeah, 10 minutes. Yeah. Okay. After the final presentation, we will open a Q&A session. Okay, ladies and gentlemen, let us begin with our first speaker. First speaker is Professor Dr. Syahrul Nizam bin Kamaruzaman. Yeah. It's my great pleasure to introduce our first speaker. Prof. Syahrul is a professor in the Department of Building Surveying Faculty of Built Environment, University of Malaya. His expertise in building performance, facility management, construction, and building information modeling. His expertise is particularly relevant to today's discussion on improving energy efficiency, building performance, and ESG implementation. Please join me. Welcome, Prof. Syahrul. The floor is yours.
Can you want it? Oh, okay. Oh, okay. All right. Thank you. Bismillahirrahmanirrahim. Thank you very much, Mr. Dr. Moderator. Good morning. Assalamualaikum warahmatullahi taala wabarakatuh. Distinguished Chair, respected colleagues, ladies and gentlemen. My name is Syahrul Nizam from the Department of Building Surveying, University of Malaya. I know it's quite unpopular, this program in Indonesia. However, it is quite popular, famous in most of the Commonwealth country when it comes to building surveying. So it is my pleasure to share my work on title Bridging Heritage and Sustainability. So I will discuss a little bit, share my work that I've conducted in terms of the energy consumption in heritage building and how should we move from a normal consume energy in building towards a more sustainable building. Allow me to briefly introduce myself. I'm from University of Malaya. My focus is on building surveying, facilities management, building performance, heritage conservation, and also energy efficiency for more than 2 decades. Throughout my academic career, I have been fortunate to lead numerous national and international grants, and we have a lot of collaborations with the international, and I think the most recent collaboration is with Undip. Today itself, I have my colleagues here in the third row, 3 tables, which I bring in from University of Malaya. They are on collaboration, summer programs with Undip. It is definitely an interesting experience, and we do hope that one day we could do this in Malaysia maybe. I come from University Malaya. University Malaya is basically the oldest university in Malaysia. It was established in 1905. Today, is ranked among 100 in the world. It is also recognized as excellence for its research, innovation, and also international collaboration. We have about 30,000 students from over 80 countries. Yeah, making a global research university. In the recent ranking assessment, we are being ranked 56, and we really hope that we will be climbing the ladder quicker towards the top 50 universities in the world. Right. This is what I'm going to be talking about. I'm going to be skipping a few slides because I was just given 10 minutes. I will focus more about the work that we have done on energy efficiency in buildings. So this is about heritage and sustainability. There is importance in heritage buildings and also sustainability. Preserving heritage is something that is crucial, especially in developed countries. We have limited lands, we have limited resources, and the most important thing is that if we choose rather to demolish a building, okay, it requires enormous amount of embodied carbon. So it is best that we retrofit existing buildings to improve operation performance while maintaining the cultural significance. So therefore, conservation itself becomes a sustainable development strategy. Right. Allow me to just give an insights about what do we understand sustainability and why it matters to us. One of the reasons why it matters to us is because buildings, building sector is a major contribution to CO2 emission. So that is why it is crucial that we look at buildings as one of the move towards embracing sustainability. We do understand, Brundtland report, we mentioned about what is sustainability, what is ESG. I think those fundamentals are being shared throughout the world. As a community, as a researcher, as a people who are involved in buildings, we should play our important role in how should we inculcate sustainability in our work. Right. If you look at heritage buildings, there are three main categories as being defined by UNESCO. One is a monument. So monument is one category under heritage or historical buildings. There are also groups of buildings like those found in Georgetown, Penang in Malaysia. And the other thing is sites. We do have UNESCO heritage sites in Malaysia, which is the Malacca and Georgetown, Penang. Yes. Those are the two cities in Malaysia that are being recognized as UNESCO's heritage site. One important thing about heritage is not just about the architectural values. There is a term that is called outstanding universal values. So when discussing heritage internationally, UNESCO introduces the concept of OUV. So a heritage building is not recognized merely because it is old or aesthetically attractive, but it must possess exceptional cultural significance that transcends the national boundaries and becomes valuable to all humanity. So, in order for us to be recognized as heritage sites, one of the important things is to ensure you have the OUV, Outstanding Universal Values. Therefore, any energy retrofit strategy must ensure that this universal value remains protected throughout the conservation process. Okay? Okay, I don't know what's this happening. Okay. Right. Before I move on, there is very interesting share of culture from between Malaysia and Indonesia. They definitely possess remarkably architectural heritage. Our historic buildings reflect centuries of cultural exchange involving indigenous tradition, colonial influences, and religious development. So this building continued to serve as an important education, culture, and also tourism function. Therefore, it's crucial that the improvement move towards environmental performance for the regional importance. Yeah. Right. Okay. This is basically a scenario or a background about heritage buildings in Malaysia. We have scattered numbers of buildings in Malaysia, even though we do have 2 sites of UNESCO's. It's keep on flickering. Yeah? All right. So total numbers that we have is about 20,000 over. I think maybe now is about 30,000 over that is listed under the Jabatan Warisan Negara National Heritage Department. So there are a large numbers. They are located in Perak, Johor, Melaka, and Kuala Lumpur. So these buildings definitely exhibits a lot of diverse architectural influence, including the Malay, the Chinese, the Portuguese, the Dutch, and even definitely the British. Allow me to share a case study that we have conducted. Before that, oh, sorry. Okay, is it? Right, okay. These are the 5 things that we do with historical buildings. So, some people preserve, some people conserve, some people restore, and most of the things when it comes to meeting the current demands of the industry, the community, the people, now we are moving towards refurbishment or change of use. Because of the limitations of spaces, buildings, and the opportunity that exist into fulfilling the needs of occupancy, these buildings are being refurbished to fulfill the needs of the country. However, right, when it comes to refurbishment. I'm going to skip this slide. I'm going to move towards this one. Yeah, sorry. Okay. Throughout my work that I have conducted for the past years, there is a trend whereby when a building is refurbished, most of the time it has the energy spike when it comes to consumption. The reason being, historical building was not designed to accommodate, full-fledged air conditioning system, aesthetic lighting systems, But when it comes to our century right now, these buildings are being fitted, they are being refurbished, are being installed, with a lot of technologies. So this has created a huge spike of energy consumption. So which is not something that should be the practice when it comes to refurbishment. So I'm sharing a simple way of looking at how should we be able to, oh my God, it's already 10 minutes, yeah? Sorry. On how should we be able to see and practice the right thing of making sure energy being consumed wisely, okay? So I'm going to jump straight to my case study, okay? This is just a quick sharing case study. Bisa, Prof, ya? 3 minutes, yeah? Okay? Right. I'm going to skip this one. Okay, right. This is a case study that we have conducted in 4 historical buildings in Malaysia. It is a British colonial building that was built during the 90s. There are 4 scenarios here. We have selected 4 types of buildings typologies. One is air conditioning standards, natural ventilated, open plan, mixed mode cellular, and also air conditioned prestige. And it is also being selected because of the space, because of the square feet, how big the buildings are. And we look at electricity bills, and we also conducted the energy audit on these buildings. Sorry. Okay. This is a study that we have conducted. What we do is basically we look at the electricity bill for all the buildings. So those are the 4 patterns that we have identified. And then we conducted a normalized performance indicator whereby we look at how should we be able to benchmark, kilowatt hours per meter square. So we have a common understanding about how energy is being consumed and how should we be able to benchmark with the international standards. So we have the figures on your bottom right is a comparison to benchmark with regards to the overall energy consumption of the building. So you can see the historic office building 1, 3, 2, and also 2, okay, 1 and 2, is obviously does not sit between typical and also good practice. So meaning, whenever you wanted to see how energy is performed, you should look at the simple way or the initial way of benchmarking your energy consumption in buildings. Or maybe other types of structure that you wanted to study on energy consumption, Okay, so those are the scenarios. And furthermore, because a building consists of a lot of equipments, a lot of segregation, a lot of groups in terms of, in terms of energy consumption. Nggak bisa Pak ya? Okay, so a further investigation was conducted to see what are the most or what are the consumption breakdown. The three major consumption or electricity consumption consists of air conditioning system, lighting, and also electric equipments. So these are the three breakdowns that we have studied, and we have also performed a calculation on each and every single energy loads or electricity loads for the building itself. This is how we conducted the calculation. So we calculated each fixtures, we times the power consumption, and we times into the hours of usage. So we'll be able to identify what are the energy consumption for lighting, for air conditioning system, and also electrical equipments. Right. So allow me to jump, to maybe a few slides. So the interesting part, I think Malaysia, Indonesia has the same scenario. We know that the highest consumption of electricity in buildings is air conditioning system. That is basically the fact. However, when you look at this study, even though the consumption, air conditioning energy consumption is high, but it is still within the typical or good practice of electricity consumption. However, lighting goes beyond the good practice of energy consumption. So what we are seeing now is that we do understand air conditioning system is the biggest consumption. However, it's still within. And when we studied and when we conducted the research, it was found that lighting was beyond the good practice when we compared to energy benchmarking. Right. So what we have decided, we went into the free resources, which is the sun, because we believe, Malaysia, Indonesia have the same climate condition. So what we did, we make full use of the sun and trying to use the sun to as a source of energy savings opportunity. All right? So we conducted this research and we simulated. Next, please. Okay, next. Right? We conducted the simulation using IES, which is Integrated Environmental Solution. We mapped all the buildings, we digital twin the buildings, and we run simulation. Next, please. Right? We conducted the daylight factors analysis. We have found some opportunities, huge opportunities that we are able to save energy through the usage of daylighting control. Okay? So, right. This is what our achievements was. You can see on the right figure, diagram there, on what is the savings that we have been able to achieve. The red one is without daylighting control, and the blue one is with daylighting control. A simple study, but it's very beneficial when it comes to energy saving. Obviously, when you save energy, you will definitely save your costs and money in maintaining the buildings. Right. So I think I'll move to my last slide to be fair to the other speakers. Right. So last slide, please. Okay. We do understand there is a huge challenges that we've got to focus on. However, it is very important that we bridge heritage and sustainability. Moving forward is towards sustainability, ESG and so forth. However, we have bugs that we've got to bring, our heritage, our culture, our community, our people, and this has got to collaborate, it has to come together, and we really hope that we will be able to achieve sustainability by also preserving our heritage. With that, thank you very much, everyone, and I do apologize for the time.
Okay, thank you, Professor, for your insightful presentation. Your discussion provided us with valuable perspective on heritage building. Okay, once again, thank you. Okay, we move to the second speaker. Ladies and gentlemen, we will now proceed to our second presentation. It's my pleasure to introduce Dr. Stephen Herwig Godeke. Okay, Professor. He is an associate professor in hydrogeology and environmental geology at University Brunei Darussalam. He holds PhD in hydrogeology from University of Tübingen, Germany, and his research expertise includes hydrogeology, submarine groundwater discharge, and tropical peatland. Okay, please welcome Dr. Stephen Herwig Godeke. The floor is yours.
Thank you very much. Thank you very much for the introduction. Thank you very much for the invitation for this conference. I really appreciate it. As you can see, I've already skipped my title slide, so I'm saving you some time here. My topic is going to be on the hydrogeology for climate resilient infrastructure, and I'm going to give you some examples of groundwater dynamics in coastal and tropical system, and I've picked the coastal peatland as a case study for you that you see here on the right-hand side. And leading on from the previous speaker, I mean, monitoring groundwater levels is obviously important for infrastructure, especially in Southeast Asia and in Brunei. The groundwater level is, on average, just below 2 meters below ground. And so we need to know where the groundwater level is when it comes to infrastructure development. So we did some groundwater mapping also in this regard for Brunei. And here for tropical peatlands, I picked tropical peatlands for you because they are, in a way, the unsung hero of climate change mitigation. As you know, they are groundwater-dependent ecosystems, and they store a vast amount of organic carbon. They act as a carbon sink, but they are often disturbed through and threatened by infrastructure development, land use change, and suffer drainage and subsidence as a result. And here on the right-hand side, so we installed, on the small figure, you see the site layout, the empty white corner in the left here. There's the South China Sea. So it's a coastal peatland, and I don't know if you can see the very small black dots over there. There are two transects that are, one is close to the infrastructure of a coastal highway, and the other one further inland is a transect that was more that we put on for close to the primary forest, which was quite challenging to get to that transect. And that peatland here has suffered from infrastructure development because there is a road that has been built. You may see it here as a diagonal line that cuts right through the peat dome, and also from the coastal highway, because the sand to have it as a substrate for the highway was taken from the layer below the peatland as a foundation, basically, and that caused a large amount of forest retreat and also subsidence and drainage. So you see for the orange curve on the right figure here, that's a piezometer which we monitor every 20 minutes, and the rainfall intensity here is like millimeter every 200 minutes. You see a sharp rise for last year's monsoon season, where we had some moderate to very high rainfall, and you see an immediate response and sharp rise of over 1 meter for this piezometer that is close to the highway and in the more degraded peatland. However, for the green curve on the more close to the primary forest, we see the peat acts more naturally like a sponge. The rise is only 40 centimeters. So with that, the lower orange curve, I mean the piezometer in degraded areas, they're much more prone to flooding from heavy rainfall. And we see that the sharper response and faster water level fluctuations in the degraded area. And also we saw when we monitored the hydrogeochemistry that the dissolved organic carbon, as example, is significantly higher in the degraded peatland area than in the less degraded. And for hydrogeological monitoring to support climate resilience, I believe it's important that we do a multi-stage approach, not just monitoring groundwater level for example, with our loggers and our tipping bucket rainfall station, the data that you saw before, but also couple it with the hydrochemistry and and possibly geophysics. So here, we used, for example, at the Butters peatland, we used electroresistivity tomography and seismic refraction. This is an example here for what you see here on the left, the figure of our transect that we did using seismic refraction for a section of the peatland that is also under threat of drainage. And you can see here, the good thing is non-invasive. So we used our geophones on this area. But you can see that the pink line, polygon there, that's basically showing you that the water, there's in the unsaturated zone, so the water level has already dropped by around 1 meter in the peat, and that shows you also from other investigations here in Indonesia. If the water level drops in peatland by around 60 centimeters, it is more prone to fire, and of course it has been affected by drainage. And we should couple this, of course, with cores, so to have a more unique interpretation of our data. And in this regard, also carbon stock assessment is important to know how much carbon is actually stored in the peatland. Because if we talk about climate resilience and supporting climate change, we need to know how much carbon is actually stored in our most carbon-dense ecosystems. And coring here is one of the methods where we analyze the bulk density and also of course, the depth of the core, and we measure the carbon content. Combining this, we can calculate our carbon stock, and we're still in process to do this for the Butters peatland. Hopefully, we can have a result in the near future on this. And then, I'm just trying to. Sorry, Yeah, thanks. So and that is already like my final slide actually. Like for groundwater science, it's important to incorporate groundwater science to support our climate change policy, hopefully support our climate change policies and for resilient land management, because of course we want to maintain the groundwater levels, for example, in the peat close to the surface to reduce peat oxidation and fire susceptibility in these areas, not only in peat, but we have other areas where due to the high carbon content, we have frequent wildfires also in Brunei due to higher temperatures, El Nino, rising temperatures. And I'm giving you one example that we've done for the Belait River catchment that you see on the right-hand side. The black boundary is the Belait River, the biggest river in Brunei Darussalam. And for that, we calculated a base flow as well as a groundwater recharge using stream flow displacement method. And you see here the small arrow there. On the left, that's basically a Batas pumping station. That's where, because I'm sure also for Indonesia, you take a lot of water from rivers, right? But also groundwater. 2 minutes. But often pumping is done without really knowing what is the sustainable abstraction rate, for example. So we did this and calculated the base flow for this river, and then came to the conclusion that when we looked at the pumping rate, luckily the pumping rate is still below 10% of the base flow for this river. So that was good news. But we really need to have a long-term monitoring for these, not only for these ecosystems, for our areas, and integrated hydrogeological data sets in order to provide evidence for possible climate change adaptation policies. And that's already what I wanted to share today with you. Thank you very much for your attention.
Thank you very much, Dr. Kudege, for your informative presentation. Your presentation has strengthened our understanding about groundwater dynamic in tropical peatland. Okay, now we move to the third speaker. Okay, it's my honor to introduce Dr. Nur Syafina. Yeah. Dr. Nur Syafina binti Roslan. She's an academic in the geology program in Department of Earth and Environmental Sciences at University Kebangsaan Malaysia. She received her PhD from Earth Science, the University of Birmingham. Yeah, her main areas of expertise include urban hydrogeology, groundwater modeling, engineering geology, and the characterization of fracture rock aquifer. Okay, please give a warm welcome to Dr. Nur Syafina binti Roslan. The floor is yours.
Okay, thank you, Mr. Speaker. So, Assalamualaikum and very good morning, everyone. Selamat pagi. So, thank you for this golden opportunity for me to share my experience. My name is Dr. Nur Syafina Roslan. So, PJOL is professional geologist. And I graduated for my degree in geology in UKM, and I did my master's in Hong Kong University, and I did my PhD in urban hydrogeology in University of Birmingham. So I'm so happy to meet a lots of hydrogeologists here. So I learned a lot. So this is second time I'm in Indonesia. No, this is the third time in Indonesia. So the second time I joined PAAI event. So allow me to share with you my experience working in fractured aquifer systems and ESG. So next. So fractured, there are two systems. Aquifer system in Malaysia. So they are coastal aquifer and also fractured rock aquifer system. So mainly for fractured aquifer systems or wells, they are mainly dominated by manufacturing industries. So this Google Map image is really from Selangor area, and the red dots really represent the pumping wells. So the industries is really varies, and and also wells also been built for construction purposes and also for quarries. And besides, Malaysia also have a lots of mineral water companies. So the second picture shows the well or the factories that sell mineral water. So the most popular one in Malaysia is Spritzer. If you travel by Air Asia, normally they will serve Spritzer as a drink in flight. And then besides, well also been built to cater water stress problem. So this is one of the system been built by the government or Mineral and Geosciences Department of Malaysia. So they drilled the well and they built the water treatment system and they hand over to the mosque or the school or universities. So UKM, my university, also have groundwater wells, and it's up to the premise to come out with a distribution or build their own distribution system. And the last one is fractured wells, fractured rock aquifer or wells been built to support irrigation, especially for paddy and also other plantations. Next. So I begin my research during my PhD using all data sets, secondary data sets. We have a lots of data such as borehole logs, pumping tests, and chemistry data. So from there we built or we developed hydrogeological conceptual model. So this kind of research or works only possible by collaborating with state regulator and government. Such as Mineral and Geoscience Department, Department of Irrigation and Drainage, NAHRIM. NAHRIM is one of Water Institute in Malaysia, and also Department of Environment. Next. So from that data, so we built, as you can see, is a subsurface profile. From here, we can identify the aquifer level, aquifer distribution, and also the aquitard or aquiclude. Next. From pumping test data, there are lots of pumping test data. It's one of the requirements if you want to obtain license. So the well owner need to submit the pumping test data sets. There are two. There are constant yield tests, and also there are step tests, and also recovery tests. So they need to. There are lots of data we need to analysis. So what I did is just analyze all of them, and then we come up with a classification. So as you can see there, we can learn that the aquifer, they are confined, they are leaky, and then they are semi-confined aquifer as well. And the three graphs down there is really from step test. So from there we can learn the aquifer behavior and also the well efficiency. Next. And also for the chemistry, the two graphs on my right, it's really, we can understand the pattern or the quality of well water in urban area. So in Selangor, the area that I'm working, as you can see, the most of the well with the low TDS and low chloride. So it's a good water quality. And as years, the second graph is 20 years span. So you can see the water still in good quality, but there are few wells with increasing TDS and increasing chloride. So that it shows that there are some pollutants detected. Next. And besides of working with only secondary data, so I also do some site visit. So this kind of research is only possible by collaborating with industries. So from here, I learn about operating and maintenance problems from the well owners. Next. By visiting, so we managed to see every premise, they have their own treatment systems because they have their own problem. And the second pictures, it shows that this is the main problem that we face in Malaysia. So our water contain high iron and high manganese. So it will create problems such as well clogs. So this is one of the things that we managed to experience if we collaborating with industries. Next. The next, from the data sets, we already built aquifer, the hydrogeological conceptual model. Then we try to do some modeling, numerical modeling. Is crucial if you want to study bigger scale, which is basin. And also, I do modeling using pumping test data to understand the aquifer behavior. And besides, we also go to the sites to do some augering and lab analysis. This is crucial because in Malaysia, the aquitard or the confining layers is really thick. So we really need to understand the behavior of the confining layers. So we need to do some experiment in understanding the character. And the last one, the isotope study. This kind of study is only possible by collaborating with other universities. So this one is being done by collaboration with the University of Tsukuba. So we managed to do this to study the groundwater recharge. Next. Yeah, next. So this is the model of the Selangor River Basin. And this is my graduated student. He from Riau. He graduated last year. Now he's working with Hulu Rokan, Pertamina. So it's really good to have like an Indonesian student come and learn. I also learn. We can learn each other. And next. Yeah, this is the model that we developed using isotope study. Next. So the last one, as a hydrogeologist, it's really crucial to do some discussion with the stakeholders. Okay, so the stakeholders that we met is, of course, the regulator, the well owners, and also we really need to get involved with the public. So we really need to do some surveys. We really need to listen what are their problems. In a way, for us as academic, to do some research. It's really as a bridge to reduce the gap between industries and also the government. And beside, as academic, we also offer training for younger geoscientists and also offer technical advices and support for the government, especially Mineral and Geosciences Department. And besides, to empower the role of a geologist, so this is what we've been done to control the quality of the hydrogeological work in Malaysia. So all the reports need to be endorsed by professional geologists. So in a way, to become a professional geologist in Malaysia, you need to have 5 years experience. So we promote the student to register as a graduate geologist first. After they graduate, and then after they work for 5 years, they will apply to obtain the professional geologist license. And then also participate in producing guidelines. So this is how we control the hydrogeological work in Malaysia. So we already come up with the Garis Panduan Pembinaan Telaga Tube, or in English, guideline for tube well construction. So all the well, if they want to build a well, so they need to follow all the procedures in the guideline. And also, I also contributed in water sector technology 2040. So this is to ensure the groundwater is there is a future for groundwater in Malaysia, because groundwater in Malaysia is only not widely used as what Indonesian situation is very different. We mainly use surface water, and some parts of the country really use groundwater, but it's a coastal aquifer. But the rest is only for manufacture. So that's why to get more people use groundwater, so we really need to get involved in this policy. And the last one, I do hope that we are working on groundwater policy. We don't have that in Malaysia, but we are working in groundwater policy. So I do hope that I can participate in this one as well. I think that's all. The last slide. I think that's all from me. Thank you.
Okay, thank you, Dr. Dorsafina, for sharing your knowledge and research perspective with us. Okay, we move to the last speaker. Ladies and gentlemen, we have now arrived the fourth presentation. It's my pleasure to introduce Dr. Irwan Iskandar, STMT, PhD. Okay. Dr. Irwan Iskandar is an associate professor and member of the Earth Resources Exploration Research Group in the Faculty of Mining and Petroleum Engineering at Institut Teknologi Bandung. He is also chairman of PAAI. His main area of expertise include hydrogeology, hydrogeochemistry, groundwater modeling, mining hydrogeology, environmental geochemistry, and water resource assessment. Okay, please join me in welcoming Dr. Irwan Iskandar, STMT, PhD. The floor is yours.
Thank you, Mr. Moderator. So today I will talk about not related with the main object of my research, but actually this is the ideas or thoughts based on discussion with our senior, with our teachers related with the issue about the environmental sustainability and governance in the framework for climate resilience, coastal development. Of course, this is very important. Now we face the Godzilla El Nino in Indonesia. Now maybe almost 1 month there is no rain, especially in Java Island. And based on the previous speaker, so I like to visit Malaysia. Several weeks ago I visited Malaysia for there is a mining in Kuala Lipis, Pahang, and there is a 35 billion liter of water, mine water, should be dewatering. It is a big problem for mining, but as my question yesterday about the mine water can be used as a new raw water resources. So that's my talk. My name is Irwan Iskandar. So this is my thought and idea. Okay, of course, Indonesia's many population or urban stay in the coastal zone, especially for Java Island, the most dense island in the world, because 280 million population of Indonesia are staying in Java Island, 60% or 70% maybe, and then most of them stay in coastal part of North Java, like in Semarang City, Jakarta cities, and the big cities or megapolitan cities stay in coastal zone of Java Island. And the problem is also the population need water resource. And Indonesia, mostly like Java, is not a continent, this is an island, so limited space. Yeah, limited space, and the population is high, so very dense, so not enough space to keep the water. Even though our precipitation annually is around 2,000 millimeter per year, but during the rainy season, we cannot keep the water on the surface and then just throw to the sea and make a flood, mostly in the coastal zone. But how the integrated study related with the hydrogeology or groundwater, architecture and built environment, and others, other subject or other discipline can work together related with this issue. Yeah, of course, the issue is population growth, the issue related with the urbanization, water needs, and others. So we cannot work alone, just only hydrogeologist, just only civil engineer, just only architect, just only environmentalist, but we must work together. Here is the moment, I think. Yeah, this is just like a figure about the building, one single building, and one single building has an impact. First, the impact is a foundation and load. Of course, because there's load on the surface and the materials, mostly geologically in Indonesia at coastal zone in North Java Island is alluvium, very soft, there's young material, still naturally consolidated or natural compaction. But at the same time, we make a building. Most of building in Indonesia, in big cities, Indonesia has a basement. Yeah, basement, maybe 20 meter, 30 meter basement for parking space. And then the watering, yeah, or depressurization, because during the digging of the basement, the water from the groundwater pump out, and then after that, the wall is cut by concrete. So maybe the building size is 5 hectares, 3 hectares. Yeah, sometime in Jakarta, the size of the building needs area more than 5 hectares. So it means around the 5 hectares, we make the groundwater drop and then cut the groundwater. And then at the same time, there is a load from the surface. And the other is a hydrogeological reaction after this infrastructure was built. First, if the groundwater level drop, is seawater intrusion accelerate. And then land subsidence, the issue, the main issue of course, Semarang. Yeah, 2 days ago we visit the proof of land subsidence in Semarang city. And also the response the aquifer itself, because we put the load and then the aquifers find the stabilization. And then how to compromise with this performance. We have building. Before we pump out the water itself, all the groundwater for the daily use, for the building, for the supporting of lives, but also during the construction itself, we already make some problem related with the hydrogeological issue. Yeah, ESG acts as the functional connector between the built and natural environment. Sometimes I thought that maybe our ancestors, our fathers, our grandfathers in tropical region like in Indonesia, they built stilt house, rumah panggung, with the zero runoff. I learned from Professor Sudarto, Professor Lambok, Professor Denny about maybe our ancestor, our grandfather, fathers built in the tropical region with the stilt house or rumah panggung is the best way for us in the some region. And now we build like most common building, like big infrastructure. Yeah, so we cannot halt the runoff because previously the land or the soil can be still infiltrate with the surface water, but now the number of infiltration decreasing by time caused by we paved the caused by the building. So how to manage? Yesterday, Professor Luo from NTU mentioned about natural solution based on the issue. The solution sometimes may be related with our natural condition, like our geology is soft material and we have a high amount of precipitation annually, and sometimes there is El Nino here, maybe we must compromise with that. So in the term of environmental issue, how the equation is, how can we protect our groundwater as Dr. Stephen mentioned before, to control or make the groundwater level is not changed. And the social problem also, how our culture, our habits deal with this issue. Yeah, about the coastal resilience, about to manage or zero runoff, or maybe in Jakarta there is a ZOBAT, zona bebas air tanah, there is no groundwater abstraction in central part of Jakarta itself, and the governance, the regulation, based on the evidence-based policy, integrated planning, and how to achieve the sustainability development goals. The question is, how do different agencies work together? Scientists, researcher, academician, and government work together, and how the groundwater still can support our lives. So this is maybe real-time integration and continuous whole system monitoring. Instead of only monitor, we already monitor in Central Java. They have several monitoring wells in Jakarta also, Semarang, Surabaya, and other big cities in Indonesia have monitoring wells, ground surface control, and others. But how to use the data integrated with the planning, integrated with the civil engineering works or architecture design. Yeah, how the technology with AI, because we use AI mostly. You can see this slide also can be built just only less than 15 minutes or less than 30 minutes using AI. I just talk with the AI and then the AI can make these slides or presentation. So, but also AI has another problem for the water issue because AI also need water to for cooling, for cooling the server and others. So this is the challenge also. And also how the outcome, a true circular economy where the subsurface data or like a groundwater monitoring, subsurface condition or ground surface change, can be used dynamically informs above ground building, efficiency, infrastructure, and load management. How to manage the area like in Indonesia, in coastal zone especially, with the soft material, we need water. Maybe in the near the future, we need like desalination or breakage water reverse osmosis. Yeah, that's another idea because we still need water. And also, we discussed this morning about the priority of groundwater permit because sometimes we use the water is mostly just for sanitation, hygienist, and take a bath, but for drinking water or potable water, just only limited, maybe just less than 5 liters per day or just only 2 liters per day. But for sanitation and hygiene, we need 150 liters per day. So maybe we must make the new policy about the priority of groundwater usage in Indonesia. Okay, next slide. So, how about the future coastal development demands, interdisciplinary collaboration? Here, there is an architect, civil engineer, law, and social scientists, hydrogeologists, geologists, mining engineers, and other engineers, and we can work together using the data based on evidence-based coastal policy because our city is located in the coastal zone area. And there is no concluding remarks from me, just several questions for Ms. Dr. Vina about the fracture aquifer. Fracture aquifer, maybe in Semarang, we don't use the fracture aquifer, but mostly in the volcanic region also there is a fracture aquifer. How to characterize the fracture aquifer and what information is still missing for the policymakers because maybe in some part of Indonesia we use this fracture aquifer. And for Dr. Stevens, in some part, in the northern part, in the coastal zone, we have also like peatland. How to support peatland for the protection and development? What are the key lessons in rapid urbanizing city like in Semarang or Jakarta and Surabaya? And also, of course, Professor Sahlur as the architect or civil engineer, how can groundwater preservation can be integrated into early stage building design? Yeah, because of course we need the building for our life, for our activities, but how to design the building, but with the zero runoff, but the limited change for the groundwater. How does the construction sector balance carbon reduction with the aquifer protection? I think that's all from me. Thank you for this time. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Dr. Irwan, for your presentation. And ladies and gentlemen, we have now heard all 4 presentation, and we'll now move to Q&A session. Yeah, we will collect one or two questions. Yeah. Okay. Okay. One, two. The first, dulu, Bapak dulu, baru Prof. Agung. Yeah.
I have 2 questions. First to Dr. Nursiana, Makcik, Malaysia Makcik. Makcik Nursiana. My question is, what kind of modeling did you use? Is it finite difference, finite element, or stochastic? That's the first question, not yet. The second question, you are dealing with fractured media, right? It's very difficult, and probably you can share a little experience what you have when you you did the modeling. That's the two questions. My third question is for Dr. Irwan. Dr. Irwan, you didn't mention anything about artificial recharge. I don't like it. Artificial recharge, I think it's one of the most important for us in order to preserve our groundwater. That's all, 3 questions. Thank you.
Okay, thank you very much, Professor Lambo. I first heard your name from Dr. Sarah. Professor Lambo, yeah? Betul. Okay, so for the first question, so for the modeling that I use is just very, we just use like finite numerical model and finite depth difference. Okay, yeah, finite difference is very generalized because as I start doing modeling, I just realized that I need more data. So that's why I stopped doing modeling and then I back to the aquifer characterization, doing all the analysis. Because I think for the beginning, it's good just to run model is very generalized one. I see some presentation yesterday. In the modeling they assign many layers. For many layers in modeling, it's very complicated. So that's why modeling is just a tool for generalize. So try to make it simple. So you will get some simple values and then you can always improve later. So that's number 1. Number 2, what? Yeah, I think that is a number 2 answers. I think it's a good. We have a lot of data, and then in Malaysia, not all area we can do modeling. Sometimes the data is only very limited, but they want to also they need to do the modeling, but you can expect the result it should be rubbish. So we just focus on the area with lots of data, then we can proceed with the modeling, and then we can get some idea, and then we have some experiment that we can do some calibration, and then we always can visit our modeling results. I think that's how we improve the modeling, because modeling, it can be, it's us who input the data, so it can be, get improved time to time. I think that's all from me. Prof, I hope it's answering your question.
Yeah, thank you, Professor Lambok. Yeah, first I would like to say apologize. It is my fault not mention the artificial recharge is one of the solution that must we conduct about the artificial recharge. But of course, artificial recharge also need money, need cost, right? Especially if we want to make a recharge for deeper aquifer in the because the problem also not only in the unconfined aquifer, shallow groundwater, but also the problem is caused by the groundwater abstraction in the deep groundwater aquifer system, or we said the confined aquifer. And to make the balance between the abstraction and the recharge, of course the artificial recharge is very important. And of course this is need cost. So that's why we discuss the idea about the water price. It should be for the conservation, not as the financial benefit of the government only, but we must pay back the groundwater tax or water price for the conservation. For example, we pay 1,000 rupiah per cubic meter. We must pay 1,000 cubic meter when we abstract the groundwater. So it means the artificial recharge like aquifer storage recovery idea managing aquifer recharge. But of course, Pak, we need money for that research, deep research. And here maybe we have some participants from the government about the water price for the conservation. Because water price now is not for conservation, but for the, what we say, pendapatan, yeah, our income, yeah, for the each province or each regency or kabupaten, kota, or city. So that's Pak Lambok. Thank you.
Thank you. And now, go to Prof. Agung.
Yeah, thank you, Mas Marcel. My question goes to Prof. Sahrul. You mentioned regarding with building performance. Can you explain, is it building performance also including the embedded energy and operational energy? And the second one is, you also mentioned the digital twin in order to be as tools in order to use and to measure the building performance. Can you explain a bit more regarding the digital twin? My second question goes to Pak Iwan. When we apply permission in order to construct a new building, I think the expert, the stakeholder, when we go to the city to ask PPK, is usually only the architect and then civil engineering, mechanical engineering, and electronic engineering. How easy that we can got the groundwater mapping maybe, if the architect want to design the building and then we can cooperate with the geologists. How easy this one? Yeah, thank you.
Wah, susah banget ya soalannya ya, Prof. First of all, thank you very much for the question. If I understand it correctly, the first question was about what's the relationship between building performance and maybe sustainability, embodied energy, embodied carbon, and the second question is about digital twin, how the digital twin will be able to assist in our energy performance, energy consumption, or maybe energy savings opportunities. Right, Prof, yeah? Okay. The simple question, the simple answer to Prof Agung's question with regards to is building performance related to embodied carbon, the answer is definitely yes. Right? When we do building performance, when you do energy consumption, when we do energy investigation, energy audits, and so forth, it will bounce back to the overall concept of CO2 emission. When we talk about green buildings as well, there are 5 major categories when we look at sustainable assessment. One of the things is embodied energy. So we have water consumption, we have energy. I think the top one is energy, second is water, third is waste, number 4 is management, and number 5 innovation. So all these related to emission, embodied carbon, embodied energy. So now there are even calculators were built to measure and calculate what will be the embodied energy consumed when construction is being built, when maintenance and operation is being planned, and also towards the end is what are we doing when it comes to demolition of a buildings. So all this relates to embodied energy and embodied carbon. The second question with regards to digital twin, I think this is quite a new technology that have been implemented around Indonesia maybe, and also Malaysia. Yes, as I mentioned during my presentation, I adopted the digital twin to build our assessment. We are also currently looking at sensors, IoTs in buildings, whereby when we have a digital twin, these digital twin are related or connected directly to the physical assistant building through sensors. So whatever happens to a building, for instance, they are in this room, if I may use this room as an example, if the temperatures or if the energy being released by human here are more than it's supposed to at the original state, the sensors will sense the thermal, what do you call it? Thermal comfort in this room, and through the sensors, the digital twin will send the message or the information to a building management system, and they would use what would be the best temperature for this room, and they would change the temperature. Initially, you might be expecting 100, 200 or 300, and the best temperature maybe is about 24.5 degrees Celsius. However, when it comes bigger, and there are equipments here, temperature rise, the system will realign, recalculate through the sensors and put out the right thermal comfort temperature for this room. So that's one of the example in digital twin. So this reflects directly to the overall energy, thermal comfort, and maybe we also talk about indoor environmental quality, which consists of 4 items, IAQ, acoustics, thermal, and the other one I cannot remember. Alright, so right, so to answer your question, yes, the first one, the second one, definitely. Digital twin is maybe the way forward for us to embrace ESGs and also sustainability. Thank you, Prof. I hope that answers your question.
Yeah, I'm feeling like doing my final defense because I stay in front of many professors here, like a PhD defense, I think. Professor Agung related with the permitting, when we want to make a new building or new infrastructure in the city, usually it goes to the city planners committee or city planners office, and there's so many civil engineer, architecture, mechanical engineer for doing construction. But of course, I think maybe Undip or Diponegoro University can push new additional data or new, not a bureaucracy, but new additional data related with the groundwater issue in that area. Because if we want to make a new building in that area, the groundwater level is already decreased by year, changed, and already subsidized, occurred. So it means we must consider start from the beginning, not already the infestation or investment already comes and make a new building and stop. You cannot build a new building over there because the groundwater cannot support. Yeah, because it's already land subsidence already occurred, or other issue related with the issue of the groundwater. So yesterday, I think one of the quantum leap or big jump from the government, the Ministry of Energy Mineral Resources already launched soft launching about the Artesis. It's a groundwater data nationally. It's a good result. I applaud to Ministry of Energy and Mineral Resources related to the Artesis data, and also maybe for the regional, regional province also can update the data. Of course, because we have one single data, everybody can use the data not only for the industry but also public, because the platform or the Artesis platform is paying or cost from our tax, right? So it means everybody can see the data of the groundwater in that area. I think one of the big important yesterday we have Artesis, one single data from the Ministry of Energy Mineral Resources, and of course updated from the regional province of Energy Mineral Resources. So the architect and the civil engineer or the mechanical engineer can see the groundwater data in that area.
Thank you, Pak Agung.
Okay, thank you, Dr. Irwan. Okay, I think enough for Q&A session. Before closing, on behalf of organizing committee and participants, I would like to express our appreciation to all speakers. Thank you for the sharing expertise, insight, and professional perspective with us. Okay, please give applause to all speakers. Okay, I will also like to thanks for all participants for your attention and active participation. This concludes our panel session. Thank you very much. Good morning and have productive and inspiring conference. Thank you.
Thank you to Engineer Marcelinus Kriswardana, PhD, for brilliantly moderating this session, and to all of our esteemed panelists for such a thought-provoking exchange.
As a token of our appreciation, we now present the certificates of honor. So may we invite the Dean of Diponegoro University School of Postgraduate Studies, Bapak Muhammad Agung Wibowo, PhD, to present the certificates to our moderator and panelists, and will be followed by a brief group of photo session.
Thank you once again to all our panelists and moderator. Moving forward, we now proceed to the sponsor presentation session with a 5-minute duration each, which will be started by the representative of PT Tirta Investama. To the representative of PT Tirta Investama, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. I would like to convey my gratitude to distinguished guests, PAAI, and also all the committee. Thank you very much for welcoming us here. In this opportunity, we will present a movie from our company, PT Tirta Investama, that you already know all our brands is Aqua. We will present a movie, and then before we begin the two movies, we would like to little bit give it the introduction that Aqua is already start the sustainability initiative, start in the early 80s. There is a lot of the sustainability topics beyond the water that we would like to share. But unfortunately, due to the limited time, we will share only some of part of the what we already do. And I would like to highlight a simple, but I think it's a critical message for us, just to have that groundwater sustainability is a shared responsibility. It's not the one party or one stakeholder responsibility, but it is a shared responsibility. So protecting the groundwaters will require integrated collaboration among the communities, governments, businessmen, academics, and also the NGO. So in the movie that you will watch, that the movie is about the journey that Aqua has been promoting nationwide through measurable, scientific-based collective action to conserve water resources and strengthen water source resilience. And then you will also see the second movie that show how this commitment is extends beyond conservation into humanitarian action. Following the Aceh disaster, that Aqua has been contributed to the emergency response efforts, with some location access still challenging right now, while others drawbacks with the science, knowledge, courage, prayer, and the goodwill. Then we managed to develop 36 water wells and also water treatment system, helping the hospitals and community and also the villages around, and it is around over 10,000 people beneficiary at the 8th Regency in Aceh and also in the Tapanuli Tengah. We hope this story inspired all of us to work together, because sustainable water management is not only about protecting resources, but also about protecting life, communities, and its ecosystem. Thank you, and please enjoy the film. Silakan start, Pak. Next movie, Pak. Okay, thank you very much for attention, and also that I would like to little bit confess when I was there about I think about 4 months we going forward, back and forward, something like that to manage this development of the well. Then you will can see how the drop of the water is very precious for this like more than over 1,000 people. Then you will see they really cry when there is a water is going out flowing and they can drink the water. So that's why I would like also to convey to make that our together here that we need to do the really collaboration to have the integrated on the water management. Thank you very much. Bye.
Thank you to PT Tirta Investama for a very wonderful video presentation. And may we invite the head of PAAI, Pak Irwan Iskandar PhD, to the stage to receive a certificate of appreciation by PT Tirta Investama. Thank you once again to PT Tirta Investama for a very wonderful video showcase. Now, may we go on ahead to the next presentation session by the next sponsor, PT Tirta Fresindo Jaya. To the representative of PT Tirta Fresindo Jaya, the floor is yours.
Ya, selamat pagi semuanya. Good morning, everyone. It's very honor to be here. Distinguished guests, I would like to begin with presentation in Indonesia, if you don't mind, because the memory of English little bit slow. The presentation is 5 minutes. So, teman-teman, Bapak Ibu sekalian, pertama atas nama PT Tirta Fresindo, produsen Limineral, dan Mayora Group, kami ingin menyampaikan terima kasih kepada Indonesian Groundwater Expert Association, PAAI, dan terima kasih terutama untuk teman, rekan, dan mentor saya, Pak Irwan Iskandar, Ketua PAAI, Kang Iwan. Nuhun, Kang Iwan, terima kasih atas kesempatan yang diberikan. Kepada para sesepuh, Prof. Heru, Prof. Lilik, Prof. Juanda, Prof. Lambok, sudah jalan ya. Udah teman-teman semuanya, izin atas nama Mayora Group dan Limineral, sebenarnya saya ingin mengucapkan terima kasih dan merasa terhormat untuk bisa presentasi di sini. Pak Fajar, selamat pagi Pak. Jadi izin di depan para sesepuh, di depan para Pak Heru, Prof. Heru, terima kasih Pak Heru, mentor saya juga. Jadi di depan para sesepuh saya izin menyampaikan sedikit step dari perusahaan, a little bit our sustainable steps from our company, our group of the company. So hopefully can bring a little bit acknowledgement about the company. Ya, silakan. So this is our product from Tirta Fresindo, the Mayora Group. This opportunity I would like to share a little bit about our mother company from Mayora. Lanjut. Rekan-rekan semua, saya izin memperkenalkan Mayora ya, supaya teman-teman juga mengenal Mayora sedikit. Jadi Mayora adalah PMDN, Local Capital Investment 100%. So kita establish di tahun 1977. Saat ini kita memproduksi 8 divisi dari permen, kopi, beverage, biskuit, coklat dan sebagainya. Yang kami highlight di sini bahwa 50% dari produk kita diekspor ke 100 negara. Ya, jadi dari 3 miliar US dollar sekitar 1,5 sampai 2 miliar US dollar kita ekspor, Prof. Kita ekspor dan kita adalah salah satu yang terbesar dari eksportir FMCG dari Indonesia. Jadi kita memberikan nilai tambah yang seluruhnya kepada Republik kita. Jadi kemudian kita mempunyai 41 pabrik, 9 pabrik memproduksi beverage, mineral, dan kita bekerja sama dengan lebih dari 70.000 petani. Kemudian kita bekerja sama dengan lebih dari 60.000 karyawan. Lanjut. Ya, jadi seperti teman juga tadi bahwa komitmen Mayora selalu berprinsip kepada pentahelix ya. Kita selalu melakukan sesuatu bersama-sama dengan 5 unsur dari pemerintah, dari media, kemudian dari industri, dari akademi seperti PAAI ini, kemudian tentu pada masyarakat. Jadi semuanya secara otomatis pada saat kita melakukan selalu kegiatan, terutama konservasi, kita melibatkan 5 unsur ini. Lanjut. Nah, Tirta Fresindo bagian dari Mayora Group ini sebenarnya perusahaan didirikan di tahun 2006. Tapi 2006 kita memproduksi Vitazone pertama, kemudian 2011 teh pucuk harum dan le mineral. Sebenarnya kita baru produksi di tahun 2015, awal 2016. Kemudian kita ada di 12 pabrik, sebarannya di 9 kota di Indonesia. Lanjut. Nah ini teman-teman, semua rekan-rekan, ini adalah produksi kita. Le mineral, teh pucuk, torabika, kopiko, nipis madu, 7 kurma, dan kolagena. Lanjut. Ini sedikit secara saya sampaikan komitmen kita terutama dari le mineral. Sejak berdiri tahun 1977, kita memulai aksi konservasi hijau di tahun 2015, kemudian 2021 kita melakukan gerakan ekonomi sirkular. Nanti saya sharing sedikit mengenai pilah sampah, kemudian peta jalan sampah dari permen LH75. Kemudian kita juga mendapat apresiasi dari Kementerian Perindustrian untuk transformasi digital di tahun 2022. Kemudian di tahun 2023 kita membangun pabrik daur ulang di Jombang. Tanggung jawab kita di dalam pasca konsumsi dari kemasan kita. Dan di tahun 2026 kita mempunyai komitmen secara keseluruhan Mayora Group melakukan komitmen secara sustainable yang nanti saya akan bisa jelaskan. Lanjut. Jadi ini Bapak Ibu sekalian, teman-teman, bahwa ini adalah secara singkat total komitmen dari Mayora Group dan juga tentu dari Tirta Fresindo, di mana sejak dari awal, sejak dari sumbernya, baik itu dari sumber air, kemudian dari sumber bahan baku, seperti singkong, coklat, kopi, dan sebagainya. Kita melakukan, mencoba untuk selalu melakukan sustainability di tempat tersebut. Kemudian kemasan dan sebagainya kita juga pilih kemasan-kemasan yang selalu mudah didaur ulang, bersustain, yang bisa kita lakukan sustainability. Kemudian di manufacturing nanti kita sharing sedikit banyak mengenai bagaimana kita melakukan reduction emission. Kemudian di distribusi kita juga sering melakukan pertemuan dengan distributor, bagaimana kita melakukan, bagaimana mereka tetap harus menjaga lingkungan. Kemudian di konsumen tentu di internally kita selalu bekerjasama dengan Badan Perlindungan Konsumen, di mana kita terus memperhatikan apa do and don'ts di konsumen supaya kita lebih bisa concern terhadap kepentingan konsumen. Kemudian kita juga melakukan collection kemasan pasca konsumsi, dan ya tentu yang tadi saya sampaikan bahwa tanggung jawabnya akhirnya kita membangun industri daur ulang plastik yang food grade di Jombang. Lanjut. Nah ini sedikit sharing sedikit mengenai 41 pabrik kita, 37 pabrik ada di Indonesia, 4 pabrik kita punya di luar negeri, tapi ini sharing sedikit secara singkat mengenai konservasi yang kita lakukan, terutama di Tirta Fresindo. Kita menanam pohon penghijauan, konservasi sumber air kita, kemudian kita jaga di lingkungan kita, di pabrik, untuk selalu mencoba untuk melindungi dan menjaga kelestarian sumber daya air kita. Kemudian di Sumatera, karena kita juga menggunakan memproduksi kopi instan, ready to drink coffee, kita melakukan kerjasama dengan sekitar 70.000 petani kopi di di Sumatera, dan kemudian di Sulawesi kita punya pabrik tapioka yang bekerjasama dengan sekitar ribuan petani di Singkong di sana. Kemudian kita juga mencoba melakukan edukasi mengenai bibit, bagaimana meningkatkan kapasitas dan menjadikan bibit yang unggul. Ya, lanjut. Ya, ini penanaman pohon yang kita lakukan di seluruh pabrik Tirta Fresindo. Terima kasih kepada Prof. Heru, Pak Boy, Pak Indra, terima kasih semuanya yang telah memberikan masukan kepada kita, di mana kita, terutama Pak Irwan yang telah melakukan, di mana kita mempunyai sumber, di mana daerah resapan kita, sehingga kita terus menjaga daya tangkap dari resapan kita. Jadi kita telah menanam dan counting 246.000 pohon, dan kita akan coba terus menghitung dan akan mencoba melakukan water balance, zero water, ya. Dan kita menghitung 533 hektar lahan konservasi yang kita konservasi. Lanjut. Ini contoh-contohnya yang telah kita lakukan di seluruh kegiatan penanaman pohon. Ini sharing sedikit aja bahwa kegerakan semuanya kita lakukan dengan pemerintah daerah, dengan masyarakat setempat, penanaman pohon, dan menjadikan tempat-tempat tersebut menjadi tempat-tempat yang baik dan dapat menghasilkan menjadi tempat wisata, penangkapan air dengan baik, dan bisa terus memasukkan air itu ke dalam sumber air yang kita ambil. Lanjut. Ini sedikit aja ilustrasi di pabrik kita, di mana tadi Pak Irwan sudah sampaikan zero runoff kita lakukan di pabrik, di mana seluruh air yang ada kita gunakan di air tidak akan keluar, dan kita akan recycle terus airnya. Ya, mulai dari ada WTP, pemanfaatan air reject, yang terus kita lakukan pembersihan untuk menjadi MCK. Kemudian kita punya rain harvesting. Kemudian kita punya juga automatic water level recording. Kemudian kita punya sumur resapan, sumur pantau yang bisa kita pantau penurunan air tanahnya. Kemudian kita juga punya embung, absorption pounds, ya, absorption pounds. Jadi di daerah sekitar pabrik kita lakukan semua yang kita dapat lakukan untuk menjaga air di sana, dan kita juga melakukan artificial recharge. 1 menit lagi, 2 menit lagi, oke, lanjut. Ya, udah, terus lanjut. Ya, lanjut deh, ini tadi udah sampaikan. Nah, ini teman-teman kita juga melakukan yang terutama di mineral, kita melakukan bahan PET ya. Jadi kita melakukan bahan yang disampaikan bahwa sebenarnya PET yang paling banyak di recycle. Dari kalau botol itu 74% terkumpul kembali, dan galon kita hampir 100% sebenarnya tidak ada di tempat sampah. Jadi kita lakukan dan kemudian kita juga collect di pabrik kita. Lanjut, ini sedikit mengenai di pabrik kita ya, kita melakukan tenaga surya, kita rubah sedikit demi sedikit, kemudian di boilernya kita ganti dari batu bara ke biomas, dari cangkang sawit, dari ampas kopi, ampas teh, kemudian dari sludge yang kita pakai kita juga bakar di sini. Kemudian kita nanti coba juga ke vehicle listrik. Ini semua sedikit. Lanjut. Ini tadi zero runoff yang telah disampaikan oleh saya. Kemudian lanjut. Ini program CSR ya, tanggung jawab sosial kepada masyarakat. Tentu kita pilih yang benar-benar diperlukan di sekitar pabrik agar masyarakat bisa merasakan manfaat dari apa yang kita produksi di sekitar kita. Lanjut. Lanjut. Ini customer protection karena kita di 100 negara kita coba untuk comply, kita coba untuk melakukan hal yang terbaik dalam sustainable. Lanjut. Ya, lanjut. Nah, ini sedikit ya yang saya mau sampaikan bahwa kita melakukan gerakan ekonomi sirkular. Ya, bahwa kita salah satu atau kita berbangga bahwa mineral itu kita mengedukasi masyarakat dalam hal pilah sampah dari rumah, karena memang pilah sampah dari rumah itu yang paling penting untuk koleksi. Kita menayangkan terus-menerus PSA ini, public service announcement, jadi iklan kita terus selama 5 tahun kita iklan dari mineral untuk memilah sampah dari rumah. Kemudian selanjutnya tentu pengumpulan, kerjasama, kolaborasi, dan kita campaign juga bahwa barang-barang bekas ini kita bisa produce menjadi sesuatu yang baru. Lanjut. Izin ya, 1 menit lagi. Ya, nah ini ya, tadi saya sampaikan teman-teman bahwa mineral adalah satu-satunya yang menyampaikan iklan announcement bahwa seharusnya kita semua aware terhadap pilah sampah dari rumah, sehingga semua kemasan pasca konsumsi bisa kita recycle dan sebagainya, karena itu yang paling penting. Ya, kemudian di TV nasional, kolaborasi semua dengan edukasi, kita kerjasama dengan seluruh lapak dan asosiasi pemulung. Lanjut. Nah, ini iklan-iklan yang menyampaikan bahwa barang-barang yang kita pakai sebenarnya bisa kita produksi untuk menjadi lebih baru lagi. Ya, oke. Lanjut. Ini sharing sedikit mengenai pabrik daur ulang. Kita satu-satunya yang di perusahaan swasta yang memiliki plan recycle plan, dan ini food grade ya. Lanjut. Nah, ini recognition, jadi kita senang bahwa apa yang kita lakukan mendapatkan perhatian dan apresiasi. Lanjut. Ya, kira-kira ya ini lanjut. Ya, jadi demikian Bapak Ibu sekalian, terima kasih. Sekali lagi Pak Irwan dan teman-teman dari PAAI, saya mengucapkan terima kasih, merasa terhormat berada di sini, dan mohon input dan mohon masukan, mohon bimbingan pada Bapak Ibu sekalian. Semoga presentasi ini dapat memperkenalkan sedikit perusahaan Tirta Fresindo, Mineral, dan Mayora Group. Sekali lagi terima kasih, hatur nuhun pisan. Terima kasih, selamat pagi semuanya. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you to the representative of PT Tirta Fresindo Jaya for a very insightful presentation. And now, once again, may we invite the head of PAAI, Pak Irwan Iskandar PhD, to the stage to present and receive a certificate of appreciation.
Petahana Integrasi Solusi, mitra terpercaya dalam menghadirkan teknologi, inovasi, dan solusi digital terbaik untuk masa depan. Kami percaya tim yang solid dan bersemangat adalah pondasi kesuksesan. Setiap hari, kami bekerja dengan dedikasi untuk memberikan layanan dan solusi yang bernilai nyata. Dari perencanaan hingga implementasi, Petahana Integrasi Solusi memastikan setiap detail berjalan sempurna. Dengan teknologi terkini dan keahlian mendalam, kami membantu mewujudkan visi menjadi kenyataan. Kepercayaan klien adalah prioritas kami. Kami berkomitmen memberikan layanan yang tidak hanya memenuhi, tapi juga melampaui ekspektasi. Kolaborasi adalah inti dari setiap proyek kami. Bersama mitra, kami menciptakan solusi yang inovatif, efektif, dan berkelanjutan. Bagi kami, inovasi bukan hanya soal teknologi, melainkan menciptakan dampak positif yang bisa dirasakan langsung oleh masyarakat dan dunia usaha. Kami percaya lingkungan kerja yang menyenangkan mendorong lahirnya kreativitas, dedikasi, dan produktivitas terbaik. Mari wujudkan transformasi digital bersama Petahana Integrasi Solusi. Karena masa depan dimulai dari solusi cerdas hari ini.
Thank you once again to PT Hana Integrasi Solusi for supporting our event today. And now, for the final session, may we invite the representative of PT Merdeka Copper Gold, Mr. Graham Robert Bell, and also to PT Aman Mineral Nusa Tenggara to the stage to receive a certificate of appreciation. And now, may we invite once again the head of PAAI, Bapak Irwan Iskandar PhD, to present the awards.
to all our sponsors for their immense support. Now, ladies and gentlemen, please enjoy a short coffee break until which we will break into the first parallel session. Thank you.
Layangmu wes tak tampak.